So last time we stopped at this example, and we had a couple of tricks there. So let's first state what is the rule, and then rebuild the two tricks. So the rule is, if I'm having and or, what usually happens is these expressions evaluate to what type? Boolean int, right? Because we don't have Boolean in C, so those kind of logical operators or logical expressions evaluates to int, correct? And we said that the value of this int is either what or what? 0 or 1, right? Because these are int, so we said originally the expression really evaluates to true or false, and we said C compilers or the C language represent false as 0 and true as 1, right? So this is basically the rule. And we said, for example, if this is true and true, it will evaluate to true, otherwise it will evaluate to false, and this is or. If any of the two operands are true, it will evaluate to true, otherwise it's false. Good. So what are the tricks then? The tricks is that we mix these logical operands, logical expressions, with the post or pre-increment. Here in this example, it's only post increment, right? And this is like we have done in the last 5 minutes of the lecture, so I wanted to revisit. So the whole idea is we want to print after all of this, what would be the value of A and B and C and D. And we said, well, this is basically a post increment, which means it only gets evaluated after the expression. So if I'm, out of my interest of evaluating C, I'm taking the old values of A and B. Well, the old value of A is 0, means false. And then here is the trick. We said that basically because this is false, one of the operands of the AND is false, you don't need to evaluate the rest of the expression. And this is why this part of the expression is not even evaluated at all, which means at the end of this statement, A is incremented to 1, but B is never incremented. Why? Because the compiler optimizes the operations. It discovers that this is false, false, and anything is false, then I don't need even to evaluate this. Good? So if we try to print B here, B would still be 1. Good? And then evaluating D, now A is 1, or anything, well, true or anything is true. So again, you don't need to increment B. So if you remember, when we printed this, we found that A is incremented twice, so A is 2, but B is still at its original value, which is 1. And the reason is, these two sides of the expressions are never evaluated, right? This room is too hot, right? It's crazy. Yeah. It wasn't like this before, right? It was a bit tough, but not like the past 2 times. I don't know really what's going on. Okay. So hopefully you don't fall asleep while we're talking. Let's see. Okay, so the trick is, if you don't need to evaluate the expression, which means you already knew the result, you will not do the post increment, right? Now the question is, what if I had a pre-increment? What if I try this example with a pre-increment? What do you expect to happen? Let's first take them one by one. If I'm trying to evaluate C, but I have a pre-increment instead of the post increment, what would happen? Yeah, but that's one thing. Like, can we start from basically from the beginning? First of all, what would be the value of A that I'm going to AND with? Which will be 1. Yeah, because in a pre-increment case, which is plus plus A, you evaluate this first. So in the interest of evaluating C, the value of A is no longer 0, it's 1. This is true. And this is an AND expression, which means you still need to see this result to determine whether the overall expression is true or false, right? So in that case, B will be evaluated, right? Well, if you had B as a post increment, it will be 1. So 1 and 1 is basically 2 and 2 is true. And if you had it as a pre-increment, it will also be 2, which means it's true, then true, true, is true, right? So at the end, C will have the value of 1, right? Because it's true. While at the end here, A is evaluated to 1 and B is evaluated to 2. Does make sense? And then if you go to the D, well, that's an OR. This will be true, so still B will not be also incremented again. Make sense? Good? So try this example at home with pre-increments. Try to mix and match we had really 4 operations here, 4 increments. Try every one of them to be pre-increment instead of post-increment and try to make sense of what's happening, right? Consider this as an exercise of this rule. Good. So going back to the precedence and associativity, we are adding there the and or operations. They come basically after all the mathematical operations, so that's already known, except maybe for the plus equal or basically the single operand expressions. On condition, condition. Yeah, so something related to the logical expressions is in fact how the if statement condition evaluates, right? So simply, if you have any expression within f, again, that's by definition, by construction, a Boolean expression, because you have a condition that should evaluate to true or false, and based on this, you execute the f or you don't execute it, right? And we said last time is that non-zero value will always be true and 0 will be false. Okay? So if I have something like this, well, what do you think? I already gave you the result here, but why that's the case? Why this condition is false? Well, this is a non-zero value, so why this is false? Yep. Great, thank you. Yeah, thanks a lot. So this is an integer division, 1/2. Well, it evaluates to 0 because you truncate 0.5, 0.5, and then because it evaluates to end, you have to drop the fraction, so it's 0, right? And if 0 means if false, then you really don't print yes, and then you go to the else and you print no. So the output will be no. What about this one? The only thing I changed is I had this 2 to be 2.0. Well, we said these two basically are immediate int or constant ints, while these two are, this is still int and this is float, right? Or basically double, right? So it is a decimal floating point, so it's double, which means the overall division would be, well, a double division, not an end division. So it gives you 0.5 in that case. 0.5 is not 0, right? So it evaluates to true, right? So in this case, you will evaluate to yes, or you will print yes. You see the difference? So now we mix it, the integer division, non-integer division, with how a Boolean expression evaluates to an int in C, and how you can put this inside an if condition. If you are confused, please ask. Good? Yeah, please. Sorry, I didn't see what. Okay. Oh, double or float. So to be more strict, this should be double. So any immediate value that has a dot something or e to the power something. So the different shapes of an immediate floating point representation is by default double. And if you want it to be float, then you can put f after the immediate value, right? So we already had this in the slides. Well, it's exactly the same slide set, but we discussed 2 lectures ago. Yep. The first one you mean, right? Yeah. Yeah, correct. Yeah, because this is basically an end division, and end division will only give you end values, right? While in the second example, it gives you a double value, so 0.5 is a valid value there. Good. Okay. So let's have some other examples. We just put this away. We already discussed this. So I already, when we discussed the equality operator, I told you it's a very, very common mistake for those that are starters in C or C++ to always confuse the equality operator with the assignment operator. So if you do an if condition and you want to say whether x is equal to 7 or not, well, in fact, sometimes you forget and you just say x equals 7. So if you basically, by accident, you put the assignment operator instead of the equality operator, the condition, well, a logical error. So what do you mean by a logical error? So the risky thing about a logical error is not a syntax error. So the compiler will not complain. But logical means it's a functionality error. So the program will not execute as you expect, right? So if you write something like this, it's a correct syntax. It will be evaluated. What would happen is that x equals 7. It's an assignment. So the assignment operator will always put x to 7. which means it's true, so it will be always true, and you will print yes, right? Even if x at the beginning was 9.5. So you see the point? Do you remember what we said, how to guard against this mistake behavior if we're writing the same code snippet here? Exactly, thank you. So start with the immediate value. So if you say 7 equal x, this is no longer an assignment valid operator because you can put something into an immediate value. And in this case, if you forget one of the equals, it will give you a syntax error. Good. So if you do something like this, well, now, definitely if you forget and write 7 equal x, you will have a syntax error. Good. So another thing related to logical operands, it's not very common in all programming languages. I would argue, in fact, it's mainly used in low-level languages, including C, mostly, and mostly also in embedded systems. And the reason is this is more like a compact form of doing an if statement. This is called the conditional operator. So I need your attention here because if you get it from the first time, it will be great. If you don't get it, it might seem confusing. So the good thing about this compact expression, it's just more or less like closer to the human intuition, right? So what you want to say is there is a condition. I want to check its value. If it's true, I will take the first expression. If it's false, I take the second one. It's just as is, right? So it's very simple. What you do is you write the condition. You write this question mark, which means I want to see whether this condition is true or false. If it's true, you take the first one. If it's false, you take the second one. Yeah, you have a third one here? Yeah. Well, that's a good question. I would say no, and the reason is this only evaluates to either true or false, right? So you only have two options. It's like if else, right? But there is no if else and then else. It's just if and else. But that said, you can really have a nested expressions of these conditional operators. What I mean is, for example, the second expression, usually in programming languages, when you write the word expression, by definition, an expression can be composed of multiple expressions, right? So if I take this is as a whole is in fact called a conditional expression. So something here, instead of expression 2, I can write another conditional expression as expression 2, right? So I can write something like, unfortunately, my pen is not working, but I can write, let me see if I have an example here in the slides. No, I don't. So let me show you what I mean. So maybe we can do this. So I can write something like, it's too slow. And this has to be small, but because that's PowerPoint. But basically, right? Come on, it's too slow. Okay. So I write expression 1, and then I write something like condition 2, this, then expression 3, this expression 4. Looks ugly, but overall, this as a whole, this as a whole is an expression, right? And well, in fact, you can think of, well, expression 4 or expression 3 can also be a conditional operator, right? But the problem with this, given that this is a compact format, the more you nest them, the harder it is to evaluate, right? So, well, it's a valid syntax, but the good recommendation or the good programming practice is if you have a very complex kind of nested conditions, it's better to use if else, right? But if you only have one condition that evaluates to one line, well, it's still very human readable to write something like this, right? Okay. Okay, so a couple of examples. if I have something like this, I would say min equal, and then x larger than y. By the way, this is the if-else example that we had before, that we try simply to take the minimum value of two variables. If you remember, we had z, and we try to take x and y, which one is minimum, and put it in z. So what happens now is I'm comparing x and y. If x is larger than y, which means y is the smallest value, right? Then I would say this expression should evaluate to y. Otherwise, it evaluates to x. And then I'm putting the result in min. Right? So min will be equal y if the condition is true. Otherwise, it will be equal x. Good. And also write something like this. Greater is basically greater than or equal to 60. If that's true, then I will print pass, assuming that the passing mark is 60%. Otherwise, I print fail. Right? So two different formats now. The expression evaluates to a certain value, and you put the value here, or you execute a certain kind of operation like printing, for example, based on whether it's true or false. Good. If I want to write this in an if statement, you would have something like this. This is the completely equivalent code to the conditional operator, right? You have the two expressions here, and you have your two statements based on the expression. So, for example, oh no, that's not. Okay, so maybe I should write it myself. So simply, if I want to write this first, let's ignore this second one, and we write the first one. See, the first one, if statement would be if condition. Okay, and then I would have something like expression one. Would have been much easier if I wrote in online GDP. Okay, so let's just do it. So if I write something like this, let's say int x equal, then here I have int y equal 10 and x equals 5 might be, then let's say int z equal, and here I say if x is larger than y, I take y, otherwise I take x. And then I just print f z equal, let's send you a line. So simply what I'm doing right now is exactly the example of the min, right? Initialize the x and y, I'm putting the minimum value in z, and then I'm printing, right? If I want to write exactly the same code into if, what I would write is to say if x is larger than y, that's basically my condition, right? I would say z equal y, and then otherwise z would equal x. You see that the if expression is basically very verbose, right? Just takes few lines and it's very detailed. While this one is more like compact. I even did the declaration of z in the same line, right? And both of these are equivalent. Is there any question? Is that good so far? So assume, for example, I want to take the min of 3 variables instead. So I do something like this. X, y, and maybe L, and then equal 2. How to write this? What do you think? How to write this using, first of all, let's take the easy path. How to write this using if else? I want to have z equal to the minimum value of 3 n's, x and y and L. So what should I do? Any idea? Something I can do, and there are multiple solutions to this, is start by comparing 2 of them. Again, comparing x and y. And then, if you go inside, that means y is the smaller, right? But you still need to compare y against L. So you have another if inside it, and say if y is larger than L, then in that case, you will say z equal to L. Else, in that case, what should be z? Yep. Y. So I excluded x from the beginning, right? So you have three variables. This is more or less like a divide and conquer approach in programming. It's very easy to take the min of two variables. So you take two first, compare them, and then you take the min and compare it to the third, right? And by the way, we can write this in a recursion way, and later on we will have a recursion lecture so we can see. But that's simply the approach I'm taking here. If I go to the else, that means which one is smaller? X, right? So that means now I excluded y. So in that case, I would repeat that code. But instead of having y, I will have x. Here it should be x. Does this make sense? I could have written it in different ways, in a more compact ways, but do you see here what I'm doing? Okay, so if I have this, how can I write it in the conditional operator then? Yep. Yeah, let's see. I guess if I will try to code what you said, and please correct me if I'm wrong, right? So your friend here is saying, well, I start also with two comparisons like x and y. Here, I know that simply y is the smaller, but instead of just taking y directly, I have another conditional operator saying that compare y and L, similar to what we have done in the else case. And then if L is smaller, twice, also is hanging. If L is smaller, then I take L, otherwise I take y. And then here, I know that x is the smaller one, so I repeat the same thing, compare x with the L. And then if x is larger, then I will take L, otherwise I will take x. So we wrote the whole kind of if else nested ones into one line. Is there anyone confused here? Does this make sense? Usually what I also seen in professional code is people to improve readability. What they do is they tend to split your conditional operators into multi-lines, because in C, in fact, having lines is okay, right? So what they do is say, first of all, I compare, and I have two expressions here, right? And in each expression, I do another comparison, right? So you do this, and sometimes you can also do this if you wish, right? So you just format it in the sense that I'm comparing this. In case of true, I'm taking this, otherwise I'm taking this. But this is still, as a whole, one line in C, right? With just better formatting. Again, how to read this? Compare x and y. If x is larger, I'm interested in y, but instead of taking it directly, compare it with L. If y is larger, I will take L, otherwise I will take y. On the other hand, if this expression is false, it means that x is smaller, so I'm interested in x, I'm dropping y, comparing x with L. If x is larger than L, I'm taking L, otherwise I'm taking x. Again, is there any question? Does this make sense? Good. So let's go back. Now, that's also a common kind of confusion in C that is called tangling else. I told you to avoid all the possible if-else problems with always having explicit brackets, right? Curly brackets. So if you have this, you will never have these problems or any other problems related to your formatting of if and else. But if you don't have brackets, what would happen? So the question now is, this else belongs to what? Does it belong to this if or belongs to this if? What do you think? In other words, this is the else of which one of the ifs? Yep.
The top one.
The top one. The reason is?
Since the second it doesn't have a bracket, it's statement one, the only statement for the second.
Good. Yeah, that's logical discussion. Good. Thank you. Any other idea? Any other opinion? In fact, and this is why I said it's confusing, it belongs to the second one, right? What you said is completely logical, right? But put in mind that the compiler moves into one instruction per instruction. And the way the compiler operates is I start by processing this F, go inside it. I told you before in one example that all the F, else, like even if it's like a very long block, it's considered one statement. This is why it's called the F statement, right? So for the compiler, any F and any of its associate F else's and else is considered one statement, right? So the compiler will take this as a whole as one statement. In C, there is no rule for indentation. It's not like Python, right? So you put it here, doesn't really matter. Maybe now because it's visually put here in verbose, you might say, okay, this really belongs to this F. But the compiler ignores the spaces. C compiler is not like Python interpreter. It has nothing to do with spaces, new lines, indentation, tabs, anything, right? It only takes brackets if there are any, or it has its own precedence constraints. So in fact, this is equivalent to this one, right? As if this else belongs to this F. Now, if I want this else to belong to this F, what should I do? What do you think? Yep. Brackets. Yeah, follow that convention that we said. If you want to open brackets like this is now explicit. The compiler will not be confused. You will not be confused. And this else will always belong to this F. So my advice is that always open brackets for F, even if it's a single line. In fact, I would even add a bracket here and bracket for the else. Good. Okay, so other things related to loops and conditions. So break statement. We had one small example of using break. Do you remember what example was this? What did we use break for before? In one of our early examples, please go ahead. In the while loop, yes. Yeah, to exit the loop, yeah, but what was the example? The example, what we wanted, yeah, it's very hard to remember. So basically, we wanted to see whether an array of inputs from a user is in an ascending order or not, right? And then we said it's just sufficient. Once you break the condition once, you are done. I don't really need to continue with the array. And this is why we use the break, right? We said, if I hit my condition that I'm really breaking the ascending, like the being in ascending order, I just break, and then now I report that this array is not in ascending order, right? So the use of a break is simply just to go outside of a loop block. Good. And because it allows you to go outside of a loop block, it's used with for, while, do, while, and switch. Switch statement is equivalent to F, but we'll come into it later on. And simply what happens in case of a break is the control exits immediately from the statement or from the block of the code. You no longer continue checking your condition and continue with iterations, right? And this also is exactly the same way in any programming language, the same way in Python. So if you have seen it before, just the same kind of logic. Continue is something that is similar to break, but a little bit different. It's also used within a loop body, so for, while, do, while. But can anyone remember from Python what is the difference between continue and break? What happens if you use the word continue? Please.
Continue just skips to the single iteration, whereas break just skips the whole.
Exactly. Thank you. So continue skips the rest of the current iteration, but it goes back to the loop header, for example, the while condition or the for number of iterations, and check and continue in your loop, right? So you skip only one iteration, right? So the remaining statement in the body are skipped, and then you execute, in fact, from the next iteration in the loop. Good. So let's have two examples here. So this is completely the same code, but in one of them I'm using break, the other one I'm using continue. What do you think is going to be printed? And in both cases, I'm really having printing the number inside the loop and then print done at the end. Let's break it down one by one. First of all, what is this condition? Modulus 2 equals 0. Yep. Yeah, exactly. Thank you. And we have used it in, again, one of our early examples to check whether a number is even or odd, right? So basically, if you have modulus 2 equals 0, that means it's an even number, otherwise it's odd. And what I'm doing here is initializing my counter to 0, having a while loop that goes until 4, so basically 4 number of iterations. And I'm checking. If this number is even, I'm printing break, and then, well, I go outside of the loop and then I print done. Well, I'm starting from 0, right? Well, 0 modulus 2 is 0, because 0 is an even number. That means I'm breaking. I skip everything, and then I go to outside of the loop and print done, which means the only thing you get out of this is done, right? You don't print any of the numbers. On the other hand, if I go here, this seems very similar, but in fact, the logic of the program is completely different. What here it prints is, it prints only the odd numbers, right? Correct? Because I start with 0. Well, 0 is even, so I continue, so I skip the printing, and then I go back to the beginning of the loop again. This is basically the main difference in continue. I is incremented to 1, which means 1 is still less than 4. Well, this condition evaluates to false, so I don't execute the continue, I print 1. So what you end up having here is 1, 3, then done, right? So you print only, so the 1 in the right-hand side prints only the odd numbers, while the 1 in the left-hand side, what does it do? It prints all the numbers until it hits the first even number, right? That's basically the case, right? Which means you will always only either print nothing or print one number, because it's all the numbers are even odd, even odd, even odd, right? So if I started from 1, for example, I will have 1 and then done, right? So you stop at the first even number. Good? So here, well, let me go back here. Here I have a few other examples to see what really happens. So in this example, I don't have any break or continue. So what do you expect to happen? It's very straightforward for loop. So what do you think? How many stars I would get? It's very easy, right? How many stars I would get? 5, right? Because simply it's just a for loop that goes through 5 numbers. I never use I here. So my iteration is j, and then I'm printing stars. So I'm getting 5 stars from 1 to 5, right? Well, what about the break? In that case, I'm checking whether j is equal to I or not, which is, by the way, 3. And then once I hit 3, I break. So how many stars I would get? 3. Some of you said 3. 2. Who says 2? Who says 3? None? So the point is that, yes, it's 2. That's correct. And the reason is, once j is equal to 3, which is I, you break. You break means exit this iteration and all the subsequent ones, right? So I don't get to print if j is equal to 3. So I only print 2 stars. What about continue? How many stars I would get? What do you think? 4, exactly, thank you. And the reason is, I'm only skipping when j is equal to I, which is 3. But then I continue afterwards. So I print for case of 1, 2, skip 3, and then do 4, 5. So I get 4 stars. Good? Okay, so I'm going very slowly on this. We have a few examples, but that's very important, because once we really have all the building blocks, we'll start building complex programs and go for more advanced concepts. So if you have questions, feel free to ask, because things build on top of each other. Good, so I will leave this example for you. And then let's go for multiple selection. So we discussed if else's. Here's another example of a nested if else. So simply, what do we do here? So we're checking the score of a student. We're saying if the student is obtaining larger than 80, well, this is maybe outstanding or excellent. Otherwise, and then I'm doing another nested if. I'm checking whether it's above 70 or not, and then I'm getting good. But the question is, if a score is larger than 70, it will get good, which means, well, 90 is larger than 70. Does it mean that I will get good for 90%? What do you think? Exactly, thank you. So the point here is that even if this condition is written as score is larger than 70, In fact, there is a hidden or implicit condition here, which is you only come here on the else, which means you know for sure you are 80 or less. Because if you were 80 or if you were larger than 80, you will never come to the else. So once you are here, in fact, you are, well, below 80 or equal to 80, right? Then you are checking this. So you see the points that like nested Fs have basically implicit conditions from their if and else parent blocks, right? So if you are above 80, you'll never come here. But once you come here, that means you are below 80. The only possibility that you will get got is something between 70 and 80, right? And then the same thing here. For the else, here I only have it as larger than 50, but definitely I will not come to the else if I was above 70, etc., etc., right? This is basically nested else. You also see here that this code is written in a way that if it's a single statement, I don't open brackets. Again, don't follow this. I just want to show you the syntax. All the time, open curly brackets and close them, even if it's single statement. In that way, it will be easier for you to read. Good. Now, something that's written here is if I remove the brackets, it's equivalent to having the brackets, and this is because of what? What is the concept that we just discussed 9 minutes ago or 10 minutes ago? Yeah. Tangling else. Thank you. Basically, the else always associates to the one directly before it. Later on, I don't think you will cover this, but usually covered in the compiler course. Another reason why the else is in fact always associated to the one before it. These kind of expressions are evaluated using stacks in compilers. So it's last in, first out. So the way it works is the compiler finds an if, put it in a stack, and then continue executing. If I find an else, I open from the top of the stack, so I find an if. I associate this else to this if. So why it's always for the one directly before it. Because all the syntax checking in compilers are in fact stack-based, right? And you will learn more about stacks in 2SI. The thing you need to understand now, if you just to remove any confusion, always put the else associated or couple it with the if before it, right? This is why we no longer need the brackets here. But again, just to show you the rule, otherwise it's a good programming practice to always have the brackets. Good? So here I'm showing you another way of, instead of using nested Fs, I'm using the if, else, if, and then else block. This is the main difference between this code and this code. Well, they are functionally equivalent, but the main difference is this is just one block of code, but this is nested Fs blocks, right? So here I'm doing if, else, if, else, if, else, right? And both are completely okay. The thing that we will stop with is or we conclude the lecture with is the switch statement. Did you cover switch in Python? No? So switch is something very similar to the if statement. So think of for and while, it's just if and switch, right? It's just the same thing. So they represent the same way, but there are cases where switch comes more natural, and there are cases where if comes more natural. If comes more natural in case of you have basically general Boolean expressions or conditions. While in the switch, if you have a variable that has different values, and based on each value, do something different. So if I go back to this previous example, this is one reason why we had this example here, is if you look into this code, for example, all the conditions are dependent on the score of the student, right? So it's a single variable that has multiple values, and based on the band of the value, I'm doing something. So I'm saying if the student had of 90, it's excellent. 80 to 90 is good. 70 to 80 is something. So it's exactly the same variable. So in that case, if you have one variable that you really want to do something different based on what value it gets, switch case is the one that comes more logical. Again, you can still use the if. They are functionally equivalent, but it makes more, well, it's more appealing or more intuitive to use the switch. So if I write the same, let me just show you the example first, and then we'll go to the rule, because this is better to understand. Here, while I'm using grade, it can also be the score from previous, which is the same thing. The grade, well, basically A, B, C, D, or anything else, F or not, that's the best. But simply the idea is you have one variable that can take multiple values, multiple cases. This is why it's called case. Based on each case, you know that it has a certain, you do something, right? You take certain score. So for example, if grade is equal to A, then I print, yeah, I know that A is above 85. And then B, then basically I do this, etc., etc. Right? So it's like similar to if else, 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 else. Something important in switch is you always have to have a break after each case. Because if you don't do this, the compiler will continue operating with the other cases. Something also that is good, and it's a good programming practice, is always finish with the default case. This default case is simply your else, that if all the conditions above it are not met, all the cases are not met, you'll go to the default. Here, for example, we checked everything. Basically, well, D is anything that is below 60, I could say it's above 50, but I can write a default statement that handles the cases that are not handled in one of these things. For example, something below 50, right? So hopefully I have the equivalent of F, because this way you understand it. Let me see. Not? Yeah, no. Maybe next time we can start by writing both. Or maybe I will leave it for you as an exercise to try at home. And then if you have questions, we can talk about them next time. So the idea is I can write exactly this program using FLs, right? Just to see the difference. And then, well, if we want to try a few things, like if the grade is B, then the output will be, well, between 70 and 84. Without the break, again, there is a logical error because simply you will get, if the grade is B, in fact, you will get 3 outputs. Everything after B will be printed as true. And this is the most common mistake I see in switch cases. If you don't have breaks, if one case is true, everything afterwards becomes as true. And then it will give you everything afterwards. So make sure you always finish your case code with break, because you only want to execute one thing at a time. Good. Yeah, this is another thing to pay attention to, is that cases have to be distinct in switch. What I mean is you cannot have 2 cases with exactly the same value. We take the simple example first. Assume that I wrote case capital A and then case capital A here. This cannot be true, because this is either or. Cases are either or, right? They are mutually exclusive, right? Here, well, these are also equivalent. Why that's the case? Why 65 and A capital are equivalent? Yep. Yeah, so basically my switch is based on the grade. Grade is a character variable. So I can really write the character variable as a character or as an int, which is the ASCII representation of the character. 65 is the equivalent ASCII for A capital. So these two are equivalent. In this case, you really get a syntax error. Good. The only type of variables that switch work on in C are integers. And this also includes characters, because characters are int by default, right? Default is optional. It's very, very highly recommended because it always takes you as, well, you covered your full state space. For example, for the grade case, you might leave the blue 50 for the default. So having default is not mandatory in C. In other languages, some other languages mandatory, but it's not a syntax error not to have default. But it's a good programming practice to always have it. The last bullet, the third bullet point here is what we discussed in the previous slide, which is, well, cases are mutually exclusive. They must be distinct, right? And multiple cases can share the same entrance. What does this mean? So simply here, I can have something like case A capital or case A small. I print something. So I can have 2 cases. Let me just write it for you. So this is what it means by multiple cases can have the same entrance. So I can write something like this, which means whether grade would get a capital A or a small a, I would do print and break, right? So the 2 cases have the same condition, right? It's like if condition or condition. It's like saying the case A capital or case A small, do that, right? Is there any question? I know that we didn't write so many examples in Switch, and to be honest, I don't see it very common in professional code as well, but it's good to know it. Please go ahead. Will it be possible to raise?
Yeah.
Oh, so your question is why C represents Boolean using n, while in fact I'm only having two values. I only need one bit, right? Which is either 0 or 1 while I'm using int or character. Yeah, you are correct. But simply C originally didn't have a Boolean. So later standards, they added like this ad hoc of underscore bool. I don't recall how it's inherently implemented, but I would doubt that it's only 8-bit, for example. The smallest thing you can have in any of memory, because all memories are byte addressable, the smallest thing is 1 byte, which is the character, which is 8-bit. You cannot have 1 bit for a variable, right? Because your granularity is just 1 byte. But I do agree with you that if we want to represent things as Boolean, it might be good if we define them as uint 8 or as a character which uses only 8 bits. That's a good point. Yeah, thank you. Okay, so input and output. This is okay. So let's conclude by these. Sorry, go ahead. You had a question? No, it has to be one value. That's also one problem of the case is that if you want a range or some sort of a more complicated expression, then F is your choice in that case. Let's conclude with this because we already adjust an enumeration of the rules we have seen before. And if I found anything new, I will just stop and we continue next time. But I just want to make sure we cover this theory such that from next time we start looking into examples. We have seen already doing formatted console operations using printf and scanf. So that's we have already done. There are some sort of equivalent, but I would say rather less used or deprecated use of put character and get character, which simply put character is equivalent to printf, but it basically prints a character only, while get character gets only a single character from the console. Printf and scanf are more comprehensive, so this is why they are mostly used, but I just wanted to show you that if you see it in code, you also understand what it does. We have seen these specifiers before. Bear with me for a minute and then we'll be done, okay? If I want to have a more formatted output, I can really do so. Printf is very, very rich in the sense that you can have very complicated regular expressions, and we have seen some of this already. For example, here is just very, very small example. In fact, we have done things that are more complex. I'm printing here an int sum. This is why I'm using the specifier %d, but then the average is more like float. So I'm using the %float. Here I don't have variables, but in fact I have complex expressions, which is also possible in printf. Good. Well, that's just an example, I guess. We should stop here because these are some tricks that I want to share with you. And maybe you will have questions about them in the midterm as well. So let's stop here and we continue this couple of slides next time. Thank you. Okay. Sorry, can you say again?
I talked with you about accepting AS, foundation, student accessibility.
Yeah. Okay, so you are registered with this.
Yeah,
And
I applied and didn't accept me yet.
oh, that's interesting. So did this in the? I guess you talked to me before. Right?
Talk to you.
That's interesting. Okay, let me check because there is another. The problem this semester is that the letters either come to me or to the other professor. Because we have another professor with the course. But I will check. But like I usually don't really reject any SAS request. So my general rule is I will accept it.
Like, also, do you like stream the meetings into like Teams or something?
I don't stream them, but I record them for
I saw some of them you post on YouTube,
Yeah.
but not all of them.
yeah, well, last lecture because we started late, so I didn't bring, but I have a recording for this from last year, so I'm going to push it. But in fact, everything is there except last lecture.
Okay.
Yeah, everything is there, and today's lecture will be posted as well.
Great.
Yeah.
Thank you so much.
For the conditional
Yeah.
that has like,
Come on. Yeah, sorry, go ahead.
for the conditional statement that has the question mark, what is that called?
Conditional operator.
Conditional, but like when we're like searching it up or something, what would I use? Because normally when I search
Conditional operator. Yeah, if you want to more example, like I mean the internet.